Hello everyone and welcome to the section 1.3 lecture, which is on lines. So, one of the biggest things we're going to start with is we're going to discuss a definition of slope. What is slope? So, the slope of a line which we usually denote with the letter m to represent the slope. So the slope is a number, and we usually denote it m. I don't really know why. That's one thing I still don't know why we denote it m. But either way, we denote it m. So the slope of a line containing 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, is given by m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is sometimes thought of as the rise over the run. So, we got to have some notes to bring up. The first of which has to be broken up into two parts, and it has to do with this rise over run thing. If you want to use this when you're looking at a graph, or if you're trying to graph a thing and using the slope and thinking of it as rise over run, there's something you need to know. It's that if going up, the rise is positive. If going down, the rise is negative. And then the second part is if going right, the run is positive. If going left, the run is negative. So that's one of the important ones that we want to know when we're talking about graphing them or trying to interpret where the next point is going to be. In fact, this is kind of instead of actually an if-then statement, this is really more like a double direction. If you're going up, then your rise is positive. If your rise is positive, you're going up. So this is a good way to figure out where you should move like your slope to find your next point, which we'll talk about in just a second. The second thing we want to talk about, the second note, has to do with the different types of slopes. Of which there are 4. So I want you to draw 4 XY grids, and you don't need to worry about scaling, so just draw some nice little graphs and then break it up into pieces with some space underneath it. Like this. Let the Jeopardy music go on in your head. Alright, so I've got my 4 XY grids, and I don't need to worry about scaling. So if you have a line that starts in the bottom left and goes to the top right as you move from left to right, this has a positive slope. And as a subnote about this, it's that the steeper the line, the more positive the slope. Meaning that the number, like the slope number, the m value is going to be bigger. It's going to be like, so to show you what I mean here, imagine that this line had like a slope of 2. Let's just, for the sake of an argument, assume that this has a slope of 2. If I were to draw this line has a positive slope because it starts in the bottom left and goes up, like you're walking up a hill as you go from left to right. And this is a steeper line. So while this slope was 2, as we're supposing it, this would probably be a slope of 4 or 5. So that's what happens when you've got a steeper line. The next one is if you start in the top left and go to the bottom right, that has a negative slope. And in a similar fashion, the steeper the line, the more negative the slope. So, just like before, but it'll be like if it's steeper, it's going to be a more negative number. And conversely, actually, which is kind of interesting, if it's a less steep line, then it will have a less negative slope. So let's just say, and to drive that point home, imagine this was like -3. If I drew this line, you'll notice this line's a lot shallower. It's a lot less steep. So if this was -3, this would probably be like -1 or -1/2 or something like that. So that's something to keep in mind. Those are the two different types of slopes that have to do with positive, negative. Now we have two other ones. If we have a flat line like this, that has a slope equal to 0. And that makes sense. If you go back to the idea of rise over run, there's 0 rise. So your rise is always 0, and you're dividing it by any run you want. 0 divided by anything is 0. Save for 0 divided by 0, but that's not the point. So these lines are of the form y equals b for some constant b. So this could be like y equals 3 or y equals 2 or y equals 5.5, who cares? But horizontal lines are always of the form y equals a number. Then the other one you have is a vertical line, like this. In this case, the slope is undefined. Now, why would that make sense? Well, think about it in terms of rise and run. You are rising infinitely because this keeps going up and up and up and never moving to the right or left. So you have like infinite rise and there's 0 run. You don't move anywhere left or right. So you're dividing by 0. And as we know, we cannot divide by 0. So that's why the slope is undefined. And these lines are of the form x equals h for some constant h. So like this could be x equals like -2 or something like that. So all vertical lines are of the form x equals a number. Now we're going to talk about the different representations of lines. So the different representations of lines. Because there's a lot of ways we could write them. The most common way that you may have already seen is slope-intercept form. And this is the form y equals mx plus b, where m is the slope and b is the y-intercept. So there's a y-intercept at the point 0, b. That is the first way to define them. So let's go ahead and do some examples with this. Let's start with one example to get things started. Start with one example to get things started. Phil, you need some coffee. So, write the equation of a line in slope-intercept form passing through -3, 6 and 3, -2. Okay. So, as a small note about jargon, about mathematical jargon, and our book, if it asks for it in a specific form, you have to give it in that format. We're going to see a couple formats in just a second, but if it asks for it in a certain form, you have to give it that way. If it doesn't, then you can give it in any way that you like. So, what do we need for a slope? For a line. You either need 2 points or you need a point and the slope. But in order to put it here, in order to put it in slope-intercept form, I need to know what the slope is and I need to know what the y-intercept is. So let's find slope. Well, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And just like with the distance formula and the midpoint formula, it doesn't really matter which one you make your x sub 1, y sub 1, and your x sub 2, y sub 2. You could choose this one to be your first one. It doesn't matter, just as long as you're consistent. So I'm going to make this one my x sub 1, y sub 1, and this my x sub 2, y sub 2. And if that's the case, then this becomes negative 2 minus 6 over 3 plus 3, because it's going to be 3 minus negative 3, which is the same thing as 3 plus 3, which gives us negative 8 over 6, which becomes negative 4/3. That is our slope. Now, how do I find the y-intercept? So, we know our line is of the form y equals negative 4/3 x plus b, right? We just found out what the slope was, so we'll just plug that in for m, but we need to know what b is. And this is where our knowledge about graphs of things and the solution and points on the graph, what they mean. What I mean by that is we can use either point to find b. So you can either use this point or like this point or this point. It doesn't matter. I guarantee you, if you want, like, I'm going to use this point. I guarantee you, if you try this one on your own, you'll get the same line. So, how do I do this? Well, negative 3 comma 6 is on the graph of this line, which means that when x is equal to negative 3, y is equal to 6. Which means I can substitute in negative 3 for x and 6 in for y, and then the x and the y's are gone, they're numbers now, and we can solve for b. Let's see that in action. So this becomes y, which is 6, equals negative 4/3 times x, which is negative 3, plus b. Nice for us, the 3 and the negative 3 cancel, but the 3 and the 3 cancel, but I still got that negative. So we got 6 equals positive 4 plus b, which gives us that b is equal to 2. Our y-intercept is 2, which means that our equation for our line in slope-intercept form is negative 4/3 x plus 2. And that's how we find the equation of a line. So, and to graph it, let's also graph it. So we're going to do a bonus problem. Bonus graph y equals negative 4/3 x plus 2. So there's a lot of ways we could do it. Yes, we're already, like, don't worry, I'll come back to this in just a second. We already have 2 points on the graph, right? So we could just plot those 2 things and connect it. It'd be a done deal. But we can also use the slope-intercept form to figure it out for us. So I'm going to go ahead and add in a little XY grid. You're probably going to want at least 5 tick marks everywhere. So go ahead and make one right now. And boom, I've got mine. So I'm going to underline this and plot our y-intercept. It's where it crosses the y-axis. Now, for the 4/3, the negative 4/3, I'm gonna put the negative up top. You could put it down bottom; it doesn't matter. Like, as an important aside, negative 4/3 is the same thing as 4 over negative 4 over 3 is the same thing as 4 over negative 3 is the same thing as negative 4/3. You don't need to write that, but that's just a fact. And so this means a quote-unquote rise of negative 4 and a quote-unquote run of positive 3. So our rise is negative, which means we're going to go down, and our run is positive, which means we're going to go to the right. So down 4, 1, 2, 3, 4, and over 3, 1, 2, 3. And we'll plot our second point, which is right here. And then we'll connect the 2 points to form a line. Now my graph isn't perfect, but look at this. I mean, like, I'm not perfect, but our 2 points were negative 3 comma 6 and 3 comma negative 2. Negative 3 comma 6, I basically got it. And 3 comma negative 2, boom. We had both of them. Pretty cool. So that's one way you can do it. You can start with your y-intercept and then use your slope to find the next point. Since this was -4/3, we go down 4 because we have a rise of -4, and we go to the right 3 because we have a run of +3. All right. Now the second representation of a line, 2, would be point-slope form. Honestly, my favorite form. And I'll explain why when we do a problem. But point-slope form. And the way this is defined is, if given the slope and a point x sub 1 comma y sub 1, we can write the equation of a line in the form y minus y sub 1 is equal to m times x minus x sub 1. That is point-slope form. I said at the beginning of this video, I think, I had to delete, like my file got corrupted, so I had to do this again. So I don't remember if I said it in the first one, but there's several, lines are going to be used throughout your entire mathematical career. So memorizing their formulas would be very, very useful. So make sure you memorize the slope formula. Make sure you memorize the y equals mx plus b formula and how it works. And then also make sure, especially if you're planning to take calculus, this will be your bread and butter when it comes to finding things called tangent lines. But that's later on. Now, let's go ahead and do some examples. Let's do 2 examples to drive home the point of why I like point-slope form more than slope-intercept form. They are both important, and they have certain areas where they're more useful to visualize, and but honestly, I think point-slope form is better. I'm stalling. Let's go ahead and do a problem. So example. Write the equation of a line in point-slope form. I hope you guys don't mind if I abbreviate point to PT. So write the equation of a line in point-slope form that has a slope of 2/3 and passes through the point 12 comma -1. Then write in slope-intercept form. All right, so solution. We're given our slope, m, which is 2/3, and we're given a point, 12 comma -1. This will be our x sub 1, y sub 1, and this is our m. So, and I'm doing this to help you practice writing it down. If you don't have it already memorized, just my suggestion is to always just keep writing it every single time you do a line problem, and you will start to memorize it. So here, point-slope form is y minus y sub 1 equals m times x minus x sub 1. So we just plug it in. Y minus y sub 1, which would be y minus -1, so y plus 1. Let me write, that looked like a G instead of a Y. So this is your y sub 1, so subtracting a -1 is the same thing as adding it, equals m, which is 2/3 times x minus 12. And that is point-slope form. That was quick. Boom, bam, done, right? That's the first reason why I like slope-intercept form. And this is the second reason. To get slope-intercept form, solve for y. That's all we need to do. And I'll show you what I mean. Because you might have been thinking, well, if I have to do it again, now I know what the slope is, but now I need to use this point to find b. You actually don't have to. So I'm going to rewrite it here. You don't have to rewrite it if you don't want to, but I recommend it. So y plus 1 equals 2/3 times x minus 12. Well, what I can do is make sure to distribute this 2/3 in. We'll get y plus 1 is equal to 2/3 x minus, and I know we hate dealing with fractions, but fractions are human beings just like you and me, and they don't want to be hated. right? Nobody wants to be hated. If we distribute it 2/3, and feel free to use your calculator on this, you will get -8. Now all we need to do is subtract 1, and we'll get y equals 2/3 x minus 9. And that is your slope-intercept form. And I guarantee you, if you did the whole y equals mx plus b, so y equals 2/3 x plus b, and you plugged in 12 for x, come on. If you plugged in 12 for x and -1 for y, I guarantee you'll find that b is -9. So that's the main reason why I love point-slope form, is because point-slope form can literally give you slope-intercept form. It can't be done the other way around. I mean, it can be, but it's very, very tedious and unnecessary. So I'm quite partial to point-slope form because it was super simple. We took these 2 points, simple in comparison, let's say that much. We just took the slope and the point and just straight plugged it in. Whereas if we wanted to do slope-intercept form, we would have had to find the slope and then we'd have had to plug the thing and solve an equation. This was just immediate. And then if we wanted to get to slope-intercept form, we needed to do some algebra. And that is our answer in slope-intercept form. Let's do another example of that. So an example is write the equation, in which I'm going to now abbreviate EQ. I'm not going to rewrite equation. I'm just going to write EQ for equation of a line in point-slope form passing through the point -2, 5 with x-intercept at x equals 4. Solution. Okay, so this is a newer type of problem, and we don't want to panic. Let's just think about it. Okay, for a point-slope form, we need a point and the slope. We have a point, but we don't have the slope. What are we to do? Well, what do we know about slope? Slope is rise over run, but it's also that formula, y sub 2 minus y sub 1 over x sub 2 over x sub 2 minus x sub 1, right? But that requires 2 points. Ooh, remember, an x-intercept is a point. This means the point 4, 0 is on the line. And that's going to be our second point. So this will be our x sub 1, y sub 1, and this will be our x sub 2, y sub 2. And so we'll find the slope, which is m equals y sub 2, which is 0, minus y sub 1, which is 5, over 4 minus -2, so 4 plus 2, which is -5/6. And that doesn't reduce any further. Now we just need to use a point and then put it into point-slope form. So the point we either have -2, 5 or 4, 0. It doesn't matter. Which one you choose. It does not matter which one you choose. And you can verify that for yourself by converting it to slope-intercept form. You'll get the same thing. But I already made this my x1, y1, so let's just stick consistent with that. So this becomes y minus y sub 1, so y minus 5 equals m, which is -5/6, times x minus x sub 1, which would become plus 2, because it's a minus a -2. I'm just going to rewrite it here just so, as a refresher. This point-slope form is y minus y sub 1 equals m times x minus x sub 1. I want you guys to try and memorize that as soon as possible. So, that's another problem. The last format that I want to talk about at the moment is what we call general form, which is ax plus by equals c, where a, b, and c are constants. Some books will require that a, b, and c be integers. Other books will be fine with them being numbers, like any number, it could even be pi or whatever. But that's what they are. They're coefficients in front of the x and y, and a constant term c. This is really used for linear algebra later on in your mathematical careers. But the key thing that I want you guys to know is you can get a line from general form to slope-intercept form by solving for y. And just to give you an example of what this is, the reason why I mention this is sometimes lines are better written like this, and they want you to find lines that are perpendicular or parallel, which we'll talk about in a second. And you need to be able to figure out the slope in order to deal with parallel and perpendicular lines. So, as an example, if you had 2x minus 3y equals 9, you could convert this to slope-intercept form by first subtracting 2x. So you get negative 3y is equal to negative 2x. Actually, I'm going to put this underneath it, not to the side. Sorry. So I'll get negative 3y is equal to negative 2x plus 9. And then I'll divide both sides by negative 3. And remember, if you divide both sides by negative 3, you have to divide each term by negative 3. So this becomes y equals negative 2 over negative 3. That would be positive 2/3 x minus 3. So you can convert general form lines to slope-intercept form. That'll be a useful skill later on. Pretty soon, actually. So now that we know about lines and their different formats, we're going to talk about perpendicular and parallel lines. Perpendicular, or parallel and perpendicular lines. So let's talk about a definition. There's two of them. Two lines are called parallel if they have the same slope. So if two lines have the same slope, but different y-intercepts. As some important little subnotes that we want to talk about is that parallel lines never intersect. So parallel lines will always increase at the same rate and they will never touch. And then as a small notation thing, this is just something I do in my notes, and so I want you to be aware of it, is we use 2 backslashes to denote parallel. And you'll see that in a second when I talk about one of these examples. But that's what, like, if two lines are parallel, they have the exact same slope. Their slopes are equal. Then we talk about perpendicular. Two lines are perpendicular if they have opposite reciprocal slopes, i.e., opposite signs and one fraction is quote-unquote flipped. So what do I mean by that? Well, we got to add a couple more bullet points. The first one is, let's look at an example of like what this means. Opposite reciprocal slopes. What do I mean by that? I will mention this just as briefly. If you're looking at the textbook or the e-textbook or whatever, they have a different formulation of it. Like they're using the very, very formal definition of what perpendicularity means, and that's that the two slopes when multiplied equal -1. But in practice, that is very, very unnecessary. And instead, just thinking about them as opposite reciprocals is perfect. So to give you two examples of what opposite reciprocals are, if I have 4/3, the opposite reciprocal of that would be -3/4. So opposite sign, so this is positive, this is negative, and then we flip the fraction. That's what it means by reciprocal. So we flip the fraction. The numerator goes into the denominator and vice versa. Those are reciprocals. Are opposite reciprocals. And another example is if you have -2 and positive 1/2 are also opposite reciprocals. Now, why is 1/2 that? Well, think about this. Any real number can be thought of as a fraction. So this is -2 over 1, or -2, and then you flip the fraction, that becomes 1/2. And this was negative, so the opposite would be positive. So that's the first little note, just as a reminder of what it means to be an opposite reciprocal. The second one, the second little subnote, is that perpendicular lines intersect at a 90-degree angle. 90-degree angle. We're not going to use that too much in this course at the moment, but in future courses, specifically linear algebra, and if you want to go into a math degree like differential geometry, that'll also become useful there. And then in terms of jargon, just like we use the 2 backslashes to denote parallel, we'll do something to denote perpendicular. We use an upside down T to denote perpendicular. So we use like this upside down T to denote perpendicular. So let's go ahead and see some action. Let's do some examples. So first example, write the equation of a line in slope-intercept form that is parallel to y equals -7x plus 3 and passes through 5, 6. All right, so solution. So write the equation of a line in slope-intercept form. Now, as I mentioned before, the great thing about point-slope form is that point-slope form can be converted to slope-intercept form, and that's what I always do. Once I learned about point-slope form, I never found your y-intercept. I never found b ever again, unless I absolutely have to. So let's think about it. In order to find the equation of a line, we need 2 points or 1 point and a slope. We only have 1 point on the line, and since it's parallel, they'll never intersect. But they didn't even give it But even if they did intersect, they didn't give us a point. So we need the slope and the point. So for the slope, let's figure that out. Since parallel, so we've got y equals -7x. That's our given line plus 3. Since parallel, m sub parallel is also equal to -7. So I wrote m sub, and that's the symbol for parallel. So that's what I mean by parallel slope. So since since our given line has a slope of -7, and these two and our line that we want to find is parallel to it, it'll have the same slope. Then we have the point that was already given, which was 5, 6. So we'll use point slope form, which I'm gonna skip writing the formula and just go right into it. So it's y minus y1, so y minus 6 equals m, which is -7, times x minus x sub 1, or x minus 5. Then what we do is we simplify and solve for y, so we get y minus 6 equals -7x plus 45. So y, excuse me, not 45, 35. Okay, so and then we add 6 to both sides to get y equals -7x plus 41. That is the equation of our line. And for the record, you are totally more than welcome to use slope-intercept form and find the b by plugging in this point. That's going to be just as fine. All right, so the last example of the lecture, and then we'll also have the extra practice problems at the end if you want to stick around. It's going to be write the equation of a line in point-slope form that passes through 5, -9 and is perpendicular to x plus 7y minus 12. Okay. So, we have a point, and we're only given one point. So, like, we do know that our line and the perpendicular line will intersect at a 90-degree angle, but we don't know where that is. They only gave us one point. So, we have a point, therefore we need the slope. Well, how do we do that? Well, we're given, equals 0. I'm sorry, I forgot to have that. This should be x plus 7y minus 12 is equal to 0. Otherwise, it was an expression, not an equation. So this is in general form. Our line is perpendicular to this. So if we find the slope of this line, we can find the opposite reciprocal to get our line. So, need slope of x plus 7y minus 12 equals 0. To do this, write in slope-intercept form. Right? Add 12, subtract x, we get 7y is equal to negative x plus 12. And then we'll get y is equal to, when we divide both sides by 7, we divide the negative x by 7, so we get negative 1/7 x, and then plus 12 sevenths. Now, I know that looks intimidating because it's got all the fractions and stuff like that, but we don't care about the y-intercept of this line. This was our given line. We don't care about that at all. We only care about the slope of this line, because that's going to give us the slope of our line that we're trying to find. So this line has a slope of 1/7, a negative 1/7, which means that m perpendicular, our line, has a slope of positive 7. So opposite sign, so this was negative, so ours is positive, and then we flip the fraction, 7 over 1 is just 7. So that is our perpendicular slope. So therefore, we got y minus y sub 1, that's our point. So y plus 9 is equal to m, which is 7, times x minus x sub 1, which is 5. And that is our line in slope-intercept form, or point-slope form. And of course, if it all asked for it in slope-intercepted form as well, then we just need to simplify this, distribute the 7, subtract 9, call it good. And that'll about do it for the lecture portion. Feel free to stick around if you want some extra practice. Otherwise, have a great day. So let's go ahead and get started with them. And kind of due to space restraints and how this program works, I had to do the extra practice problems on 2 pages. So here's the first page. And so feel free to pause it and write them down, or wait until we actually do the problems themselves. And then this is the second page. Feel free to pause it and write it down, or you can wait until we actually do each problem. So we got this one. Question 1. Determine if the lines y equals 2x minus 3 and 2x plus 4y minus 9 equals 0 are parallel, perpendicular, or neither. So, if they were parallel, that would mean same slope. If they were perpendicular, that would mean opposite reciprocal slopes. Opposite reciprocal. Or neither would be neither one of those. So, the first line, y equals 2x minus 3, that has a slope of 2. I should use a different color. I'm not like m equals 2. Now this other one, versus 2x plus 4y minus 9 is equal to 0. We first need to get this in slope-intercept form, right? Because that's the only way we can really find the slope. I mean, there's other ways. There's like formulas that you can use for general form, but it's unnecessary. Let's just get it in slope-intercept form. Moving the 2x and the negative 9 over, we get negative 2x plus 9. Divide both sides by 4, we get y is equal to negative 1/2 x plus 9/4. So the slope of this line, let's use pink, equals negative 1/2, right? So they're not the same number, right? This is 2, that's negative 1/2. They're definitely not the same number, so they're not parallel. However, the opposite reciprocal of this would be, since this is 2 over 1, would be 1/2, but we want the opposite in its sign, so it's negative. So these are opposite reciprocals, which means that these are perpendicular. And that goes for question 1. And we move on to question 2. So find the equation of the line L in slope-intercept form given the following graph. So we want to find the equation of L right here. So, technically speaking, you can already see 2 points that are on the graph, right? And so you could do this by slope, you could do this by finding the slope, choosing a point, and doing it that way. But I want to caution us there. What if these weren't given? What if these points weren't given and the y-intercept was some weird number? Maybe the y-intercept was like negative 1.1. And there's no way to guess that unless we knew exactly what the point is. So this is how we're going to do it. We're going to notice, first off, that L and y, the L in this line, y equals 2/3 x plus 2, they intersect at a right angle. This means that they're perpendicular. So, perpendicular. So, since given slope is 2/3, the slope of our perpendicular line, which is L in this case, is going to be negative 3/2. Next, and I forgot to write this, but we can just use this point here, right? So we could use the point, we could use a point like 2, 2, or whatever that is, or 0, 5, but we don't need to. Our y-intercept of L is 5, which means that B is equal to 5. Remember, B represents the y-intercept. So we don't have to do too much more. We can just plug and chug. So y is equal to negative 3/2 x plus 5. And we're done. That's it. If we didn't know where the y-intercept was, we'd probably have to start with slope-intercept form or solve for B, one of those two things. But we lucked out here. And that completes question 2. Moving on to question 3, it says arrange the slopes of M1, M2, M3, and M4, which correspond to L1, L2, L3, and L4. And arrange them from most negative to most positive. So this is where we got to go back all the way to the beginning. So I'm just going to kind of stop and go back to that for a second. Right to here. Now don't worry if you didn't finish writing stuff down, I'm coming right back to it. But this stuff is going to be key here. So lines that go from the bottom left up to the top right, those are positive slopes. Ones that go down as you go from left to right, those are negative slopes. And lines that are horizontal have a slope of 0. And then we learned about the steeper the line, the more positive or negative the slope is, depending on whether or not it's a positive slope or negative slope, respectively. So we can use that to our advantage. So let's go back to the problem and look at this and say, as a note, L1 and L3 are positive slopes, right? They're both starting in the bottom left and going to the top right. This one's pretty shallow. This one's a little bit steeper. And then L4's slope is 0. I know my picture isn't perfect, but that's supposed to be a horizontal line. So L4's slope is 0. And last but not least, L sub 2 has a negative slope. We don't know what it is. I mean, granted, we could probably figure it out by choosing the points or whatever, but that's not the point. Funny. Instead, what we're working on is noticing that this is a negative slope. So it's like -2, -3. That's the most negative. So M2 is the most negative. Then L1 and L3 are both positive. L4 is 0. So L4 is going to be less than L1, and like the slope of L4 is going to be less than the slope of L1 and L3. So that's the next one, which would be L4. Like, I know it's kind of weird, these are L's and these are M's. This is the slope of L2, this is the slope of L4. Last but not least, we gotta look at L1 and L3. Remember, the steeper the line, the more positive it is. So L3 has a bigger slope. So then it goes M1, the slope of M1, the slope of L1, and then M3 for the biggest one. And that's the arrangement from most negative to most positive. So most neg over here, most positive over here. Kind of a tricky problem, but really kind of fun. I also just love the colors. And that completes question 3. Last but not least, we have question 4, which is write the equation of a line in slope-intercept form that has x-intercept at -2, x equals -2, and is parallel to a line that passes through 2, 2 and 4, 10. Okay, so then the wording here is a little bit tricky, so we need to pay attention to what's going on. We want a line that has an x-intercept of -2 and is parallel to a line that passes through 2, 2 and 4, 10. So, if we need to if we want to write the equation of a line, we need either 2 points or a point and a slope. We have 1 point because this right here says that we have the point -2, 0 on our line. Then this piece right here, this tells us that our parallel line has a slope of m equals, this will be our first point, this will be our second point, so 10 minus 2, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, so x sub 2, 4 minus 2, that gives us 8 over 2, which gives us 4. That's the slope of this line. That means that our line, which I'm going to write m perp, has a slope, or sorry, m parallel, has a slope of also 4, because parallel lines have the same slope. Then what we got to do is, we also have that point that was given, was -2, 0, because the x-intercept is at x equals -2. That's where it crosses the x-axis. Doing this, we do y minus 0, and you don't even need to write the minus 0 if you don't want to, and then m, which is 4 times x plus 2, because it's minus a -2, because it's x minus x sub 1. So it becomes plus 2, and then the question asks for it in slope-intercept form, so all we need to do is simplify. The left-hand side goes down to y, and then we get 4x plus 8, and that is in slope-intercept form. And that completes question 4. All right, guys, I hope you enjoyed, and I will see you next time.